The James Webb Space Telescope's key pointing instrument is working well in testing, according to two space agencies involved with the observatory's commissioning work. The Fine Guidance Sensor, or FGS, a contribution from Honeywell on behalf of the Canadian Space Agency, successfully locked on to a specific guiding star in tracking mode on Sunday, February the 13th, the CSA reported on Thursday, February 17th. With FGS working well so far, the instrument will next be used to assist with the ongoing alignment of the 18 hexagonal segments that make up the primary mirror of the telescope, the CSA added. Last week, Webb engineers released a first image of a single star showing many separate views from different mirror segments, which was expected since alignment is ongoing. The Webb represents the culmination of decades, if not centuries of astronomy, says a planetary scientist and astrophysicist at MIT, Sarah Seeger. We've been waiting for this for a very long time. JWST is usually billed as a replacement for the Hubble Space Telescope, but others view it as its successor. Scientists began thinking about a follow-up even before the Hubble Space Telescope launched in 1990. After more than 3 decades in space, it's unclear how much more time this boundary-breaking satellite will be able to scan and photograph the universe. Initially, the Webb was supposed to launch in 2010 and cost around $1 billion. Its price tag grew to $10 billion, and it is way overdue. Even so, the wait will be worth it, at least according to scientists who expect new and revealing glimpses of the universe. We're going right up to the edge of the observable universe with Webb, says an assistant professor of astronomy at the University of Texas in Austin, Caitlin Casey. And yeah, we're excited to see what's there. The Webb will be better than the Hubble in multiple ways. For instance, it will allow astronomers to look out further in space and further back in time. It will look for the first galaxies and stars of the universe. In addition, it will allow scientists to make careful studies of many exoplanets, planets that orbit stars apart from our Sun, and even embark on a search for signs of life there. In the coming weeks, with the help of the FGS, each mirror segment will be carefully adjusted to stack these individual segment views and calibrate with the rest of the telescope's optical elements to ultimately create a highly focused image of a single star, the CSA said. A NASA statement about the milestone posted on Thursday included commentary from both René Doyon, principal investigator of the Canadian-built instruments on Webb, and outreach scientist Nathalie Hulette of the Université de Montréal. The two scientists discussed the function of FGS and what to expect in the coming weeks. To ensure Webb stays locked on its celestial targets, the FGS measures the exact position of a guide star in its field of view 16 times per second and sends adjustments to the telescope's fine steering mirror about 3 times per second, the scientists said in the statement. Speaking about the milestone, the scientists said they were thrilled that the guiding is working well so far. They're also looking forward to FGS continuing to assist Webb's near-infrared camera with pointing in the right direction. From now on, the alignment process of the telescope mirrors will take place with FGS guiding, while NIR cam images provide the diagnostic information for mirror adjustments, the scientist added. Webb's commissioning period is expected to take several months, in large part because the instruments are still cooling after its December 25th launch and month-long journey to a Lagrange point deep in space. The instruments are designed to operate at minus 384 degrees Fahrenheit or minus 233 degrees Celsius as Webb seeks out heat-emitting objects in the universe. The thing is, you really want to be up to date with the James Webb Telescope. This isn't enough on its own. There's actually more to this story that you definitely haven't heard about before. And that's why you really shouldn't ignore this video here, because it's going to take what you've learnt and make it 10 times more powerful, maybe even 100 times more. One of the James Webb Space Telescope's first studies will seek to tell us more about 19 nearby galaxies and how they fit into our neighborhood's history. The infrared images taken from deep space will allow Webb's data to add galactic information about star formation, strong winds blowing off the stars to disturb gas and dust, and mature stars potentially hiding in spiral galaxies. NASA's James Webb Space Telescope, the agency's successor to the famous Hubble telescope, launched on December 25, 2021, on a mission to study the earliest stars and peer back farther into the universe past than ever before. Webb is currently at its observing spot, Lagrange Point 2, nearly 1 million miles away. It's the largest and most powerful space telescope ever launched. Webb is currently in the middle of a commissioning period, with engineers focused on getting its 18 hexagonal mirrors into alignment and slowly testing and turning on the instruments. That work is going well so far, NASA has said, and the expectation is Webb will begin science observations in the summer. JWST touches on so many different phases of the stellar life cycle, all in tremendous resolution. Janice Lee, Gemini Observatory chief scientist at the National Science Foundation's NOIR lab in Arizona, said of the new study in a statement, "Webb will reveal star formation at its very earliest stages, right when gas collapses to form stars and heats up the surrounding dust. The Multi-Wavelength Galaxy Survey Program is known as FANGS, Physics at High Angular Resolution in Nearby Galaxies. The program includes 100 specialists worldwide who are seeking to understand star evolution from youngsters to maturity and beyond. The galaxies under consideration are visible face-on from Earth and on average about 50 million light-years away. Multiple observatories have already studied these galaxies, each bringing their own talents to the analysis. That includes the Atacama Large Millimeter/Submillimeter Array in Chile, which has studied 90 galaxies in microwave light, letting astronomers map which molecules are found where. The Very Large Telescope, also located in Chile, has also taken part in the project with its multi-unit Spectroscopic Explorer instrument. MUSE for short, captured the light fingerprint of 19 galaxies in the later stages of star formation, once the regions are clear of gas and dust that impede many types of observation. And the iconic Hubble Space Telescope has also taken part, studying 38 galaxies in visible and ultraviolet light and offering high-resolution images. Webb's role will be to seek out those zones of the galaxy filled with dust, which are rich in forming stars but are difficult to view in other wavelengths behind infrared. Benefits of the study from Webb will include figuring out the ages of stellar populations to build a more robust statistical models of galaxy formation and learning about the role of dust in forming galaxies, the study says. As a whole, this information will allow researchers to learn about the timeline of star formation and how that formation takes place in the context of a galaxy. Timescales are critical in astronomy and physics, Lee said. How long does each stage of star formation last? How might those timelines vary in different galaxy environments? We want to measure when these stars free themselves from their gas clouds to understand how star formation is disrupted. The thing is, if you really want to be up to date with the James Webb Telescope, this isn't enough on its own. There's actually more to this story that you definitely haven't heard about before. And that's why you really shouldn't ignore this video here, because it's going to take what you've just learned and make it 10 times more powerful, maybe even 100 times.